Good morning, all. In previous lecture, we have seen some examples related to linear differential equations of the form dy by dx plus py equal to q, and the another form dx by dy plus px equal to q. Then reducible to LDE forms, that is f dash y dy by dx plus p f of y equal to q, or f dash x dx by dy plus p fx equal to q. Then Bernoulli equation dy by dx plus py equal to q. It is similar to Bernoulli equation, only right side contains extra term y raised to n, that is q y raised to n, or the another form dx by dy plus px equal to q x raised to n. So these forms we have seen in last few lectures. So let us see the first one, which is the simple one, that is the if the given differential equation is of the type m dx plus n dy equal to 0, and if you check that, and or by checking the condition, this condition my equal to nx, that is partial derivative condition, partial derivative of m with respect to y and n with respect to x, where m and n are, m is the coefficient of dx, n is the coefficient of dy. Then if we can prove that this given differential equation is exact, then its solution is given by this formula, integration of m dx plus terms in n free from x dy equal to c. So if the given differential equation is exact, then the solution is by this formula. And if the given differential equation is not exact, that is, if we fail to check this condition, equality condition, or if you get my is not equal to nx, then we can't find the solution by this formula. This formula is only for those differential equations in which we can satisfy this equation, that is, in which we get my equal to nx. Then only you can use this formula. Otherwise, we have to use the rest of the four formulae for finding first integrating factor, and then again by this formula we can find the differential equation solution. So here, if the given differential equation is non-exact, that is my is not equal to nx, then first step is we have to find, or we have to use the one of these four rules, and first find the integrating factor, that is if, and then by using some theory steps we have to convert the non-exact differential equation to exact differential equation by multiplying this integrating factor to the given differential equation in question, and then automatically that after multiplication whatever we get, that differential equation automatically becomes exact. So there is a theorem, so you can directly write which is exact differential equation after multiplying integrating factor. And once we get the exact differential equation, and then you can use this formula. So this formula is for exact differential equation. So if we get the given differential equation is non-exact, then first find integrating factor by using one of these four formulae, then multiply the if integrating factor through the given differential equation, and write directly this is your exact differential equation, and use again this formula to find the final solution of the given differential equation, given non-exact differential equation. So here these are your formulae. So solve y square e raised to xy square. Some of the examples we can see which are exact, non-exact. So first example is solve y square e raised to xy square plus 4x cube dx plus 2xy e raised to xy square minus 3y square dy equal to 0. So first, as the given differential equation contains dx dy in numerator, so you can check this exact condition. So for that we have to compare the given differential equation with m dx plus n dy equal to 0. So by comparing the given equation with this, so dx coefficient here is m, So here dx coefficient is your this bracket, so this is your m value. So m equal to this first bracket dx coefficient, and n means dy coefficient. Here dy coefficient is this bracket, second bracket, so this is your n value. So you can write this given equation 1 is of the form m dx plus n dy equal to 0. So by comparing we get this first bracket. By comparing this given example with this equation, we get m equal to first bracket, that is dx coefficient, and n equal to dy coefficient, that is second bracket. So now check this condition, exact condition, and then use this formula if we get the given differential equation is exact. So my means m partial derivative of m with respect to y. So here m contains two variables x and y, and when we get this concept you know already, because this whole chapter partial derivative we have studied in engineering mathematics 1, that is in m1. So okay, so for more details you can refer the m1 book. So here the m contains x and y variables, and we have to find, or we want m derivative with respect to y. So m derivative with respect to y, so that time we have to keep x as constant, remaining variable as constant. So here 4x cube is your constant term, so constant term derivative is 0, that is your formula. So we have to take only this way, this term derivative. So keep x as constant and take the derivative with respect to y, general derivative with respect to y, which is your total derivative, 12th standard derivative. So here there is a product y square into e raised to x y square. So first y square contain y variable, e raised to contain this y variable, hence there is a product, and hence we have to use product rule, or product rule of derivatives. So here y square as it is, take e raised to derivative. So here we have to take e raised to xy square derivative. Here x is constant, so e raised to xy and y square is variable. So here we have to use e raised to bracket formula. So e raised to bracket derivative is e raised to bracket into derivative of bracket. So here e raised to xy square, so b value is xy square. So put b value here. So e raised to, this is your b. So e raised to b into derivative of b, that is e raised to b into xy square derivative. So now remaining value is, we have to find derivative of xy square, that is derivative of b. So when we take the derivative of b, that derivative is with respect to y. So here x, in partial derivative with respect to y, x is constant. So here x is constant, and which is in the multiplicative form. So keep x as it is, that is your rule, or you can take as a trick or hint. So whatever the constant is in the multiplication form or in the division form, we have to, when you take the derivative of the whole term, we have to take that constant as it is in the answer and take the remaining term derivative. So here x is multiplicative constant, write as it is, and y square derivative with respect to y is 2y. Y square derivative with respect to y is 2y, because x square derivative with respect to x is 2x. So hence y's first term as it is, product rule, we are applying product rule. Y square as it is, second derivative is e raised to derivative by using e raised to bracket is e raised to bracket into bracket derivative. In bracket derivative x is constant and y square derivative is 2y, plus second function as it is e raised to xy square into y square derivatives, first derivative is 2y. So first function as it is, second derivative, and second function as it is, first derivative, plus 4x cube with respect to y. 4x cube is constant, so derivative is 0. So this is your my. Then nx equal to, so nx is, we have to take derivative with respect to, now derivative is with respect to x, so that time y is constant. So with respect to This is your n. So with respect to x, so again 2xy you can consider as 2xy is your first term, e raised to xy square is your second term. So in 2xy, x is variable, it contains x variable, and in e raised to xy square there is a x variable again. Hence we have to use the product rule. So 2xy as it is, e raised to xy square. Now we have to take e raised to xy square derivative with respect to x. That time y square is constant. So again we have to use e raised to bracket formula, because e raised to single variable we have the derivative e raised to x, but here not a single variable is given, so there is a another term, that is we have to use e raised to bracket formula. So e raised to b is e raised to b into derivative of b, so this is your b value, e raised to b. So e raised to xy square derivative is e raised to xy square into derivative of xy square. So now we want derivative of xy square with respect to x. Here we have taken derivative with respect to y. So x is constant, write x as it is, multiplicative constant, and y square derivative is 2y. So here with respect to x, y square is constant, so it is, which is multiplicative constant. So y square as it is, x derivative is 1. So here first function 2xy as it is, e raised to derivative is e raised to xy square into xy square derivative with respect to x is y square into x derivative is 1, that is y square, plus e raised to xy square as it is into 2xy derivative with respect to x. So here 2y. So constant into x, 2xy derivative with respect to x. So here with respect to x, 2y is constant. So we are using kx derivative. Kx derivative is k. So 2yx derivative with respect to x is 2y only, because 2y is constant with respect to x, partial derivative. Then minus 3y square. So minus 3y square derivative with respect to x. So with respect to x, minus 3y square is constant, so derivative is 0. So this is your nx, this is your my. So check that both are same or not. y square e raised to term 2xy plus e raised to term 2y. So both are same, hence we can write my equal to nx. So equation 1 is exact. So solution is, the formula is integration of m dx plus terms in n free from x dy equal to c. Now we can see what is the meaning of terms in n free from x. So here first term, put the value of m. So this is your m, integration of y square e raised to term plus 4x cube dx plus terms in n free from x. So this is the value of n. So free from x means the equation, the terms which doesn't contain x, that is free from x means we have to take the terms from this n, the terms in n. So we have to pick out the terms from the n, so that it doesn't contain x variable, or in which we have to select the terms from this n in which x is absent, x variable or x term, x variable term is absent. Free means absent. So here this first term contain x variable, so minus 3y square doesn't contain x, so take only minus 3y square. So terms in n free from x is only minus 3y square. So pick that only term and take the integration. So here minus 3 as it is, y square derivative with respect to y. So y square integration with respect to y. So this is your 12th standard integration. X square integration with respect to x is x cube by 3. X square integration is with respect to x, of course. So x cube by 3. We are using x raised to n formula, x raised to n plus 1 upon n plus 1 integration. Then y square derivative with respect to y. Again variables are same, so same integration is there. Y cube by 3. So minus 3 as it is, constant is there. Y square integration is y cube by 3 equal to c. Then first integration is, here we have to take the integration with respect to x. So 4 as it is, x cube integration with respect to x is x raised to 4 by 4. Again we are using x raised to n integration formula. And then in this y square is constant with respect to x. In integration also, whatever the multiplicative constant, here we are taking integration with respect to x, so we have to keep y as a constant term, or y term as constant. So here y square is multiplicative constant, write as it is, and we have to take only integration of e raised to xy square. So e raised to xy square integration. So again here integration is with respect to x. So here again we have to use bracket formulae in the integration. So bracket formula in integration for e raised to bracket is e raised to bracket upon derivative of bracket. In derivative concept, this derivative of b is in multiplicative form, and in integration concept, this extra term derivative of b is in the denominator. That is the only difference in bracket formulae from derivatives and integration concept. So e raised to b is your this. So e raised to b integration is e raised to b upon derivative of b. So this derivative with respect to x is y square only, because with respect to x, y square is constant. So constant into x, kx formula, derivative is k. Hence y square into x, derivative is y square. So e raised to x y square, e raised to x y square integration by using e raised to bracket formula is e raised to bracket upon derivative of bracket. So x y square derivative with respect to x is y square. So simplifying, y square get cancelled. Hence we get the final solution. So this is the example of exact solution. The next is x square minus 4xy minus 2y square dx plus y square minus 4xy minus 2x square dy equal to 0. So now compare this equation with m dx plus n dy equal to 0. So dx coefficient is m. So this is your value m. Dy coefficient is n. So this is your value of n. So whatever the dx coefficient, that is your value m, and dy coefficient is n value. Now find the my and nx, the exact condition. So my means m derivative with respect to y only. That time x is constant. And n derivative with respect to x, that time we have to keep y as constant. So my, so with respect to y, x square is constant, derivative is 0. So with respect to y, minus 4xy derivative is minus 4x, because minus 4x is constant, and y derivative with respect to y is 1, because x derivative with respect to x is 1. Then minus 2y square, so minus 2 as it is, minus 2 as it is, and y square derivative with respect to y is 2y, because x square derivative with respect to x is 2x, y square derivative with respect to y is 2y. So simplifying, minus 4x minus 4y. Then nx with respect to x, y square is constant, so derivative is 0. Minus with respect to x, minus 4xy, in minus 4xy, minus 4y is constant. X derivative with respect to x is 1, that is minus 4xy derivative with respect to x is minus 4y. Then minus 2x square, so in which 2 is constant, write as it is, and x square derivative is 2x with respect to x, of course. So minus 4y minus 4y, both are same, so we get my equal to nx. So equation 1 is exact. So the solution is integration of, same formula we have to use, integration of m dx. So integration of, this is your value of m, put here m value x square minus 4xy minus 2y square, m dx plus terms in n free from x dy equal to c. So this is your value of n. So we have to pick the terms which doesn't contain x. So this term contain x, this term contain x, this term, in this term we have to take, because this term in this term x is absent. So take y square. So terms in n free from x is only y square. So y square dy. So y square with respect to y, integration is y cube by 3, because x square integration is x cube by 3 by using x raised to n formula. X raised to n plus, same formula is there. X raised to n integration is x raised to n plus 1 upon n plus 1. Hence y square integration is y cube by 3. Then take the integration of first x square integration with respect to x. So x square integration is x cube by 3. That is, we have to increase the power by 1. X raised to n integration. Standard formula. So x square integration is x square, x raised to 2 plus 1 upon 2 plus 1. That is x cube by 3. Then minus 4xy integration with respect to x. So with respect to x, minus 4y is constant. Write as it is in the multiplicative form and take the integration of x. So minus 4y as it is, x integration is x cube, x square by 2. So x integration is x raised to 1. So x raised to 1 plus 1 upon 1 plus 1, that is x square by 2. Then last, minus 2y square. So minus 2y square is constant with respect to x. So carefully check that with respect to which variable we are taking the integration or derivative. So the integration is with respect to x. So minus 2y square is constant. So minus 2y square is constant. So constant integration is k integration with respect to x is constant integration with respect to x is kx. Hence minus 2y square integration with respect to x. So here minus 2y square is constant. So minus 2y square as it is, and we have to take the x. So this formula we are using. So minus 2y square as it is into x. So simplifying we get the solution. Next is 2x by y cube dx plus y square minus 3x square upon 5 raised to 4 dy equal to 0. So compare with the m dx plus n dy equal to 0. So this is your m value, this is your n value. So m and check the condition, exact condition. So my equal to nx. So here m derivative with respect to x we have to take. So m derivative with respect to y. So with respect to y, 2x is constant, right as it is, and take the derivative only for 1 upon y cube. So for 1 upon y cube, take in numerator y raised to minus 3. So y raised to minus 3 derivative with respect to y, that is x raised to minus 3 derivative with respect to x. So x raised to minus 3 derivative is minus 3 x raised to minus 3 minus 1 minus 3 x raised to minus 4 minus 3 upon x raised to 4. So y raised to minus 3 derivative is minus 3 upon y raised to 4. Same variable is there, only instead of x we have to take the derivative with respect to y. So here x is variable, here with respect to there is again x variable. So same variables. So this is your 12th standard derivative or integration. Derivative. So y raised to minus 3 derivative with respect to y is minus 3 y raised to minus 3 minus 1, that is minus 3 y raised to minus 4 minus 3 upon y raised to 4 minus 3 upon y raised to 4. So minus 3 2 is minus 6x upon y raised to 4. Then n is this. So for taking the derivative in simple form, separate out these terms. So y square upon y raised to 4, that is y square cancelled, 1 upon y square, and minus 3x square upon y raised to 4. So with respect to x, now take nx. Nx means n derivative with respect to x, that time y is constant. So 1 upon y square is constant, so constant derivative is 0. Then take only this derivative. So in which with respect to x, minus 3 upon y raised to 4 is constant, which is in the multiplicative form. So minus 3 upon y raised to 4 is constant. So take x square derivative with respect to x. So x square derivative is 2x. So simplifying we get this. So both are same. Hence my equal to nx. So equation 1, given equation is exact. So solution is integration of m dx. M value is this 2x upon y cube dx plus terms in n free from x. So this is your n, which we have simplified by separating the terms. This is your term. So terms in n free from x. If you take this n whole, then we can't get the free from x term. That is, we can't get the term which doesn't contain x if you take the whole term. So for the second term in the formula, we have to carefully take this terms in n free from x. So for that we have to simplify n first and then put the value in the formula here. So free from x terms means first separate out and simplify. If you take this, we can't get the terms in n free from x. That is, the term in which x is absent, we can't get. So for that, simplify this first. So by simplifying, we get the term free from x, that is the term which doesn't contain x, that is x is absent. So take only 1 by y square because this term contains x, so only we have to pick this term only. So terms in n free from x dy equal to c. So terms in n free from x is 1 upon y square in n. So put 1 upon y square dy equal to c. Now take the integration. So with respect to x, 2 upon y cube is constant, right as it is. X integration is x square by 2 plus 1 upon y square integration is take in numerator y raised to minus 2 and use the x raised to n formula in integration, that is x raised to n plus 1 upon n plus 1. So y raised to minus 2 integration is y raised to minus 2 plus 1 upon minus 2 plus 1, that is y raised to minus 1 upon minus 1. Simplifying, we get minus 1 upon y, that is final answer. Next is dy by dx plus y cos x plus sin y plus y upon sin x plus x cos y plus x equal to 0. So if you consider this dy by dx directly, but it is you can check in roughly that this is not a LD form, because dy by dx plus py, we want y variable term separately, but we can't. There is a y variable, but we can't separate out this y, or for dx by dy form it is not possible. So you can roughly check that this is your not LD form, not Bernoulli form, or reducible form. So then we have to check for exact non-exact condition or non-exact formula. So for that, we have to first convert this given example into m dx plus in this form, dx dy in numerator equal to 0. In this form we have to first convert this equation. So for that, take the cross multiplication. So dy into this term plus dx into this term upon dx into this term. Then take denominator term dx into this term on the right side. So this is in the denominator in the left side. So dy into this bracket plus dx into this numerator upon dx into this bracket equal to 0. Then take, I have written directly that form m dx plus n dy equal to 0. So roughly you can check this. So dx into this bracket take on the right side. So this is 0 into dx term is 0. So we get dx bracket plus dy bracket equal to 0. So which is your m dx plus n dy equal to 0. Only the sequence, in the sequence dy comes first and dx last or in the second position. So it is okay, there is no any difference. So just check that, or carefully we have to take the m value and n value, because dx coefficient is your m value, dy coefficient is your n value. So don't remember like that the first position term is your m value and second position term is your n value. It is not like that. The dx coefficient is your m value and dy coefficient is your n. So at which position dx dy doesn't matter, just carefully check where is dx and where is dy. So here dx coefficient is your m, so this is your m value, dy coefficient is your n value. Now find my and nx, check the exact condition. So my with respect to y, x term is constant, so with respect to y cos x is constant, right as it is. So cos x as it is, and y derivative with respect to y is 1 because x derivative with respect to x is 1, plus sin y derivative with respect to y. So sin y derivative with respect to y. So 12th standard derivative, because here variables are same. So sin x derivative with respect to x is cos x. So sin y derivative is cos y right here. Then plus y derivative with respect to y. So y derivative with respect to y, again 12th standard derivative, that is 1 because x derivative with respect to x is 1. Hence y derivative is 1. So this is your my. Then take nx with respect to x. Sin x derivative is cos x, plus with respect to x cos y is constant, right as it is. These are your partial derivatives. Hence we have to take remaining variable as constant. So with respect to x, y is constant. With respect to y, x term is constant. So with respect to x, cos y is constant, multiplicative constant, write as it is. X derivative is 1 plus, again here x derivative is 1. So both are same, equation 1 is exact. Hence the solution is integration of, write the formula, write the formula first. So you can get the minimum marks for the formula also in the exam. So integration of m dx plus terms in n free from x dy equal to c. So integration of m is your this value, y cos x plus sin y plus y dx plus terms in n free from x, that is we have to pick the term in which x is absent. So this term in which x is present, this term in which x is present, this term in which x is present. So there is no any term in which x is absent. So we have to pick x absent term. So if we don't get any that type of term in which x is absent, then we have to take 0 directly. So this is important step. So if we don't get the term in which x is absent, then take terms in n free from x dy is 0. So 0 dy equal to c, that is nothing. So 0 dy equal to c. So this integration is 0. So just check for this integration. So with respect to x, y is constant, write as it is. Cos x integration is sin x, standard formula. Or you can raise the question like cos x, we have to find cos x integration. So create the question, cos x is the derivative of, and fill this blank, whatever the question mark you have to fill here. So that is your answer of this integration. So cos x is the derivative of sin x, hence cos x integration is sin x, plus sin y integration is, so with respect to x, sin y is constant, whole term is constant, so constant as it is. So integration of, if there is a 2 and we have to take the integration with respect to x, so 2 as it is, and dx integration is x, or there is a 1, or you can use directly the formula k integration is, with respect to x, k integration is kx. This you can use directly. Hence sin y is constant, so with respect to x, sin y constant as it is, and dx integration is x, plus y is constant, write as it is, dx integration is x. So first multiply dx to each term and take the integration. No need to write that step, directly take the integration, which is your answer. Then next example is, so here x square plus y square in dx minus xy dy equal to 0. So now here in roughly we have to check first that the given example is in, if the given example is in the form dx dy in the numerator, dx in numerator, dy in numerator. So you can go for the exact non-exact conditions to check these conditions or to use these formulae. Otherwise, if there is a dy upon dx, dx upon dy, this type of terms, then you can go for the, for checking the LDE question, LDE exam, LDE formulae or Bernoulli formulae or reducible formulae. So as dx dy in numerator, so check for the exact non-exact condition. In roughly we have to check first, and whichever the correct form, that form we have to take in the final sheet or in your answer sheet. Don't write the all the rough calculation in the fair, just check in the rough. So here m value is x square plus y square, n value is this is important. Here don't take n equal to xy only, we have to take with sign also. So n value is minus ny. Then my equal to m derivative with respect to y. X square is constant, derivative is 0, y square derivative with respect to y is 2y. Then nx, n derivative with respect to x minus y is constant as it is, x derivative is 1. So both are not same, so given example is non-exact. You can write directly one sentence that given equation 1 is not exact or non-exact. Then go for the further rules. So here, if the example comes exact, then this is your formula. If non-exact, then we have to check for this, check these 4 rules, and we have to first find integrating factor. So in these 4 rules, first rule is my minus nx upon n. So we have to find this term, and if this comes fx only, then if is e raised to integration fx dx. And then take a reverse term. First two rules are same. So reverse nx minus my upon m. Then this should become fy only. Then if is e raised to fy dy. Third and fourth are little bit same. So if the given differential is of the form y dx plus x dy, and the remaining term will be product form, that is x and xy terms should be there. Except this y, the remaining terms will be productive equations, that is x into y terms. So we will see these type of examples further. And then x dy, remaining terms in the form of xy terms, x into y term. X dy equal to 0, then directly you can take if equal to 1 upon mx minus ny, so that the denominator should not be 0. So this form is easy to check directly the given example is in the form or not. So this is easy to check first. So here again the next is, if the given differential equation is homogeneous. Homogeneous means in m and n each term have the same power. All terms should have same power, same degree. Then the if is 1 upon m into x plus n into y. This m into x is different, and this my and x are different. These are the partial derivatives, and in this rules, the m is multiplied by x, n is multiplied by y. That is the difference. So these two rules are same, and these two rules are same. In these two rules, we have to check till this step. That is, we have to first find this my minus nx upon n. Then by simplifying, first we have to check, or first we have to calculate this fx or any term. Then only we can say that the given example is of this type or this type. Say both the rules are little bit same, but these rules you can check directly by seeing only the given example, given differential example. Given example is homogeneous or not, given example is y dx plus x dy form or not. So in example, if the example comes non-exact, then check first these two rules and then these two. So sequence is 1, 1, 2. In this both are look like same, so you can you can check any rule from these two. So 1, 2, and then 3, 4. So here if you see, this is not a y dx plus x dy form. X dy is there, but in this y dx is not. So this is not of the type. We want y dx separately, x dy separately. So here x dy is there, but y dx is not. So this is not of the type. Then homogeneous is, check for the homogeneous condition. So in this m, first term is x square, so power is 2. Second term is y square, the power is 2. So powers are same. Again check for the n. In this n, minus xy is term. So x power is 1, y power is term. So we have to check for the total power of that term. So this term is your minus xy. So minus xy power is 2. So in n, power is 2. 1 plus 1, that is power is 2. In m, power is 2, 2. So all the terms having same power, that is 2 in this example. Hence this example is your homogeneous. So this example is of this type. So first check these conditions and then these two. So this is your homogeneous example. So first in roughly we have checked for the exact condition. So it comes non-exact. Then check for the 4 rules. Among these 4 rules, this fourth rule, that is homogeneous condition, is satisfied. All the powers of the terms in m and n are same, 2, 2, 2. Hence this is your homogeneous example. So what is the if value? If is 1 upon m into x plus n into y, provided that the denominator should not be 0. So we can check that. So here, so if is 1 upon m into x, n into y. So m is your this, n is your this. So first multiply m with x. So x into x square plus y square, that is m into x plus n value is minus xy. Carefully take with minus sign. So n into y. So multiply x to this, multiply y to this, we get this term. So xy square get cancelled. So remaining is 1 upon x cube. So this should be non-zero. 1 upon x cube is non-zero. Now the further steps are 1 upon x cube is non-zero. Now further steps are, we have to multiply that if to the given differential equation. This is your non-exact condition. Write only one sentence and roughly you can check for the exact condition, non-exact condition. Then equation 1 is homogeneous. Then if, we have calculated if. Then next step is multiply that if to the given differential equation. So if is 1 upon x cube, multiply 1 upon x cube to the given equation. 1 upon x cube, given equation 1. Now multiply 1 upon x cube to each bracket, this bracket and this term. So x square upon x cube, 1 upon x plus y square upon x cube dx, minus x cancelled. So y upon x square dy equal to 0. And directly write, this is your important sentence. Directly write, after multiplying if, whatever we get, that example automatically becomes exact differential equation. No need to check this exact condition again. So that is the important step. So after multiplying if, this is your exact differential equation. Write only one sentence, this is your exact differential equation. So as once you get exact differential equation, so that is your equation number 2. Now the further steps are repeated. If once we get the differential equation which is exact, so for that the exact differential equation solution formula is same. So use again this formula. So here this is your exact differential equation and solution is same. Integration of m dx plus terms in n free from x dy equal to c. So which m value we have to take, because in given differential equation this is your m value, this is your n value, but this is your non-exact equation. To use this formula, and this formula is only for exact differential equation, and we get this equation as exact differential equation. So in this differential equation we have to take m value and n value again. So this is your m value dx coefficient and this is your n value dy coefficient. Now put the value in the solution formula. So integration of m dx, this is your m, plus integration of terms in n free from x. So in this n value, there is no any term in which x is absent. So here x is present in this term, minus y upon x square. X is present. Hence take 0 dy equal to c. So take the integration. So 1 upon x integration is log x, standard formula, plus y square upon x cube integration with respect to x. Y square is constant, right as it is. 1 upon x cube integration is, take in numerator, x raised to minus 3 integration is x raised to minus 3 plus 1 upon minus 3 plus 1. X raised to n formula, x raised to n plus 1 upon n plus 1. So x raised to minus 2 upon minus 2, that is plus minus minus y square upon 2. X raised to minus 2 means 1 upon x square. That is your final answer. Next is x square y minus 2xy square minus x cube minus 3x square y dy equal to 0. So this is your dx dy in the numerator. So you can check for exact non-exact rules. So this is your m dx means this is your m dx plus n dy equal to 0. So this is your, by comparing we get this dx coefficient is m, this dy coefficient with minus sign is your n value. Now check for exact non-exact condition in roughly. So my with respect to y, so with respect to y, derivative is x square y derivative with respect to y is x square, because x square is constant, y derivative with respect to y is 1, minus with respect to y minus 2x is constant, right as it is, and y square derivative with respect to y is 2y. That is your x square derivative is 2x, so y square derivative is 2y. Simplify, then nx is with respect to x. So minus x cube derivative is minus 3x square, plus in this with respect to x, 3y is constant, right as it is, x square derivative is 2x. So simplifying, we can't get these two values as equal. Hence my is not equal to nx, or you can just write these are not equal values. Hence equation 1 is non-exact or not exact. So if you get the non-exact condition, then check for these rules. So in these 4 rules, 1, 2, 3, 4, check these first 2 rules, these 2 rules. So homogeneous and then y dx plus x dy form. So is it homogeneous or not? So in m, this term power is x square power is 2, y power is nothing means 1. So 2 plus 1 is 3. Then xy square power is 1 plus 2, 3. In n, power is 3, 2 plus 1 is 3. So in m and n, all the terms having power 3. That is, this is your homogeneous example. Take as a tutorial. The next is y raised to 4 plus 2y dx plus xy cube plus 2y raised to 4 minus 4x dy equal to 0. So compare this given differential equation with m dx plus n dy equal to 0. So this is dx coefficient, that is your m value, dy coefficient, that is n value. So take my with respect to y raised to 4 derivative is 4y cube, because x raised to 4 derivative is 4x cube. X raised to 4 derivative is 4x cube, because x raised to n derivative is nx raised to n minus 1. Standard formula. So x raised to 4 derivative is 4x cube, y raised to 4 derivative with respect to y is 4y cube. Then 2y derivative with respect to y is 2, because 2x derivative is 2, 2y derivative with respect to y, 2x derivative is 2, same variables are there, so 12 standard derivative. So 2y derivative with respect to y, same variables, that is again 2. Then nx with respect to x, y cube is constant, right as it is, x derivative is 1, plus 2y raised to 4 is constant with respect to x, hence constant derivative is 0, minus 4x derivative with respect to x is minus 4. So both are not equal, hence it is given equation is non-exact. Then check for the 2 rules, it is homogeneous or not. So for homogeneous, check the degree. Power is 4, power is 1. So no need to check the powers of these three terms in n. So here powers are not same, hence it is not homogeneous. So here power is 4, here power is 1. So hence no need to check further. So equation 1 is not homogeneous. Then the next is y dx plus x dy form. So here take y common. We can take y common. So y cube plus 2 dy plus you can't take x common. So because here x is not there, we can't take x common from the second term. So here this is not the y dx plus x dy form. So now check for the first two rules. So in this example these two rules fail, hence go for these two first rules, either this or this, both are the quite similar. So find my minus nx upon n or nx minus my upon n. So in roughly you can check this my minus nx upon n. My minus nx upon n. My value is this 4y cube plus 2 minus nx minus y cube. Minus nx means, so multiply minus sign to this. So minus y cube minus plus 4 upon n. N is this xy cube plus 2y raised to 4 minus 4x. So this is 4y cube minus y cube, 3y cube plus 2 plus 4, 6 upon xy cube plus 2y raised to 4 minus y cube. And rule says that this should be equal to f of x only, that is f of x or constant. So in x variable only we have to find the answer, or this should be f of x only. So this is not in x variable only, it contains y, so it is not of this type. So now check for the nx minus my, second rule. So nx minus my upon m. So nx value is this minus my value is this upon n. So now simplifying, y cube minus 4y cube, that is y cube minus 4y cube minus 3y cube minus 4 minus 2 minus 6 upon this same. Take minus 3 common, y cube with 2, take y common, y cube with 2. So bracket is cancelled, so we get minus 3 by y, that is wholly in the form of y only. So this nx minus my upon m should be in y variable only, and we got that. Hence this example is of this type. So f of y only. Then the next step is nx minus my upon n equal to f of y. Once you get f of y only term, then if we have to calculate. If is e raised to integration fy dy. In these two rules, find 1 upon mx minus ny, m into x minus n into y, or only there is a plus sign for homogeneous, m into x plus n into y. And directly that term here, that term is your if, integrating factor, in these two rules. But in this two rule, first we have to calculate this term, my minus nx upon n and nx minus my upon n, and that is your not if. For if there are separate rule. If equal to e raised to integration that term into dx, if equal to e raised to integration that term into dy. So if there is a fx only, so fx dx. If there is a fy, then fy dy. So that is the difference. So e raised to, if is e raised to fy dy. So minus 3 by y dy. So minus 3 as it is 1 upon y. Integration is log y. So with respect to y, 1 by y integration. So 1 by x integration with respect to x is log x, your standard formula. Hence 1 by y with respect to y integration is log y. So e raised to minus 3 log y, simplify this. So take minus 3 in power. So e raised to log y raised to minus 3, e log get cancelled, y raised to minus 3, that is 1 upon y cube. Now further step is, first step, we checked all these 4 rules and this rule is matched to this example. Then we find fy minus 3 by y, then if. Next step is, we have to multiply this if to the given differential equation. So equation 1 into if, that is 1 upon y cube. So 1 upon y cube into this. Directly by cancelling some terms, you can directly write this term or this differential equation, which will be your exact differential equation after multiplying if. Directly write this. So 1 upon y cube. So divide by y cube to this bracket. So separately divide by y cube. Y raised to 4 upon y cube y plus 2y upon y cube is 2y upon y cube is, you can check this. By practicing you can directly write this y raised to 4. I will show you, upon y cube dx plus 0 upon y cube is 0. Now separate out these terms and cancel the terms. So y raised to 4 upon y cube y, 2y upon y cube 2 upon y square dx plus xy cube upon y cube. Separate out the terms. Xy cube upon y cube get cancelled, x plus 2y raised to 4 upon y cube 2y minus 4x upon y cube dy equal to 0. So this is your term after multiplying the equation. So right, this is your exact differential equation. So whichever your exact differential equation, in this we have to find the m and n value, because here we are using the this formula, and this formula is for only exact differential equation. So this is your exact differential equation. Put the value m and terms in and free from x, and m and n value are in this exact differential equation. So comparing with this exact differential equation with m dx plus n dy, this is your m value, this is your n value. So for solution is integration of m dx, put this value m plus terms in n free from x dy equal to c. So in this we have to pick that, or we have to select that term in which x is absent. Here x is present, here x is present, here x is absent. So we have to take only this term, 2y dy equal to c. Take the integration. Y is constant with respect to x, so constant integration is constant into x. So y into x is in your integration plus 2 upon y square. So its integration with respect to x is, this is your constant term, write as it is. So constant integration is, k integration is with respect to x, k integration is k into x. So 2 by y square is constant, so constant integration is constant into x plus 2 as it is, y integration with respect to y. So x integration with respect to x is x square by 2. This is your integration, x raised to n formula, x raised to n plus 1 upon n plus 1. So y integration with respect to y, again 12 standard formula, y square by 2. Simplifying, we get the solution. We will see the exercise in the next lecture. Thank you.